to be going into this matrix menu, which is right here, matrix, which is second x inverse. And we're going to be going in there like countless times. But we don't want to make an arithmetic mistake by trying to do our all of our row operations on our own. So it's totally worth it. So we go into the matrix menu, second x inverse. And we have to edit to define our matrix the way we want it. We have to tell the calculator that it's a 3 by 4 matrix. We have 1, 2, 3 rows and 4 columns. And please stop me and ask, any question that you might have along the way. 3 by 4. Now at this point, if you're using an 83, you won't be able to see the 4th column. You would have to use the right arrow button and scroll to see it. So it's kind of, it's very unfortunate, but it's more of a pain than it is, anything that'll keep you from getting the problem right. Okay, so we start inputting the entries. -1, 5, -1, 100. We're hoping that the big numbers are going to keep us from having to use a lot of fractions. Very composite constants over on the right, so maybe that'll happen. 350. And row 3 is 2, enter, -8, enter, 1, 250. Okay, so matrix A is defined. That is our initial matrix. And now we are going to do row operations on this matrix. And the row operations, they're exactly what you learn to do from the media. To create a 1 in row 1, column 1, probably what we just want to do is just take the negative of the old row 1 to create a new row 1, which is just going to result in changing all the. Okay, so now let's work on B. Okay, this is B right here, and we need to do a row operation on B. Well, according to our goal, we want to get a 0 right there in row 2, column 1. So this is going to be what? -6 of these plus this, right? -6 times row 1 plus the old row 2. That'll be the new row 2. Now, in the calculator, the language is different, obviously. And so to do this, what this is in the calculator, in the same place where you have RREF, you have this thing called times row plus. Okay, so what I'm going to give you here is another way to write the same exact thing as this. So these two things are the same. One is kind of a human way to write it, and here's a machine way to write it. And when I'm done filling in this green box, you'll want a screenshot of this because you need to, make sure you want to have this somewhere. Okay, so times row plus, they give you an opening parenthesis. Now, the calculator, it takes 4 arguments. The first one is a value. The second one is what matrix you're using. The third one is row multiplied by. Row multiplied by. And the fourth one is row added to and replaced. For this particular row operation, the value is -6. The matrix is B. The row multiplied by is 1, and the row added to and replaced is 2. Okay, so that's the row operation using the calculator's language for it that we have to do. Now, okay, so matrix B, go back into the matrix menu, edit, or math submenu, okay? Now you can scroll down, you can scroll up, you can just hit the number, which actually in this case is a letter. There's RREF, that's the answer key. There's times row plus. So we input the 4 arguments. -6, B, so we have to go back into the matrix menu to get the B. Second matrix, B, it's on names, B, 1, 2. And it will do the row operation, whether they are integers, fractions. Again, these are this is a row operation on B, not A, not the matrix, not the lower one that we see on the screen there, but the upper one. Okay, so there's our 0 that we wanted in row 2 of this column. Store it in B before you forget. Store it in B. Names, B, enter. Okay, so you can see we're getting closer then to our goal matrix. Row 1 stays the same. And row 3 is going to stay the same. Row 2, calculator tells us, is 0, 7, -3, 750. Row 3 at the moment is 2, -8, 1, 250. Okay. Well, the next time we run this, it's still going to be times row plus, which is the row operation that you're going to do anytime you want to create a 0. You have to use times row plus. If you are trying to create a 1, which is what we want to do sometimes, then you'll have to use a different row operation. The arguments this time are going to be what? We're always going to use matrix B. Anyone? We want to create a 0 right there.
Would it be -2?
Value is -2. Matrix is B. What are the two rows? I like the way he puts the row up. He doesn't even make an equation or use an arrow. He just has the little operation at the appropriate place. Oops. So value is -2, matrix is B, the row multiplied by is again 1, and row replaced is 3. Back into the matrix menu, math submenu. It's actually quicker if you scroll up to F times row plus. Input the 4 arguments. -2, B, hey, give me that one. Come on, calculator. I might have to refresh my calculator because which is really unfortunate because it took time to define those matrices, but I started this at my office hour this afternoon and it did not hold up. Silly of me to think that it would. Let's see here. Hey, it's still there. Can I go back up? Row multiplied by is 1, because that's where the 1 is, right? That's where the 1 is. In row 1, row replaced is 3. Give me a 0. Okay. Now, let's store it. No arithmetic mistakes. which you're really going to appreciate once we go get a 1 in row 2, column 2, which is what we have to do according to our goal matrix. We have to get a 1 right there. What? Oh, and we have to write down, obviously, for credit, what we see here. We were hoping we would be able to avoid fractions, but it's not happening. Now, what is the row operation that's going to give us a 1 where that 7 is? We're not going to be adding anything. It's just a multiplication, okay? So to create a 1, what do? We just multiply a row by a number, okay? What number is that going to be? And if someone's putting something in the chat, please let me know. What do we multiply row 2 by at this point in the game? Well, it's going to be the reciprocal of what we see there. We have to change a 7 into a 1. Multiplying it by 1/7 is going to be what happens with that. That's how you make a 7 into a 1, is multiply it by its reciprocal. Now, what is this in calculator ease? Well, it's not times row plus, it's times row. And there are 3 arguments. Okay, so not 4, but 3. Now, what do you think the 3 arguments are going to be? It's totally predictable if you remember that for times row plus, it was value matrix row multiplied by row replaced. What do you think the 3 arguments are now? What do you think the first argument is? It's the same thing. What's the second argument? Same thing. What's a third argument, though? Well, if the last 2 were rows, because you had 2 different rows, The last one here is just row because you only have one row involved. So the row here is 2, but it's just row. It's the only row involved. The values are, well, 1/7 and B. The arguments are 1/7, B, and 2. So back into the matrix menu, math submenu, times row, which is E. 3 arguments, 1/7, B, two. Give me a 1. Okay. So that's a 1. Now, you see some nasty decimals there. And if you put that on your paper, I'm okay with that. But if you would like something nicer and something which is actually more practical for this problem, we're going to convert it to a fraction. And the way we're going to convert it to a fraction is the same way we've always converted anything to a fraction, using a TI. Math, enter, enter. And that's what we'll write on our paper. Let me store it before I forget. Store it in B, because we don't want our next row operation to be on an old matrix. So 0, 1, -3/7, 750 sevenths. Okay, well, we created the 1. Now we're going to create zeros. And the row op is going to be, okay, everybody paying attention, right? 5 of those plus that, right? That's going to give us a 0. 5 of those plus that. So the row op is in row 1, 5 times row 2 plus row 1. Okay. So now row 2 is the one with the 1. And that's going to be the thing that we multiply by the value. So, and that's my total recommendation, again, referring to Selah's question, is just do it this way every single time. Don't vary from it, because the more you do it, the better you'll get at it, the more you'll understand what you're doing. Okay, so we're working in row 1 here. And we're going to do five times what we see in row 2 plus what we see in row 1. So rows 2 and 3 won't change. but we'll do this row op on row 1. In the calculator, this is going to be a times row plus. So matrix, math, scroll up, times row plus, so F, not E, but F. 4 arguments, value, which is 5, matrix, which is B, comma, row multiplied by is 2, row added to and replaced is 1. Give me a 0. Okay. I guess you could do 2 row ops separately in a calculator, but only write it down once. That would be okay. So what do we get? We get 1, 0, negative 8/7, 3,050 sevenths. At the same time, it's going to be negative 2 of those plus that. Negative 2 times row 2 plus row 3 will be the new row 3. Now we still have to do it on this matrix, so we still have to store this matrix. Store it in B. If we didn't, we would get the row 3 that we want, but we would lose the row 1 that we want. Okay, so we're going to change these. Of course, we have to do it in a way, it's not like any old way that we could do to get a 0 right there would be okay. Only one way will not only create the 0 that we need right there in row 3, column 2, but will also preserve all the progress that we've made all the way along the way. To do that, we're going to use times row plus. We're going to do this row operation that we just wrote down in red. So matrix menu, math submenu, F, value matrix, row multiplied by, row replaced is negative 2, B, row multiplied by is 2, row replaced is 3, give me a 0, store it. Write it down for credit. 0, 0, negative 1/7, 1,650 sevenths. Okay. All right. Well, we need a 1 in row 3, column 3. We're going to get that by multiplying by the reciprocal. What's the reciprocal of negative 1/7? Negative 7/1. So the row operation that we do on row 3 here will be negative 7 times the old row 3 will be the new row 3. I guess it's supposed to be brackets. A lot of people try to avoid that some way. Just don't use some other math notation that means something else. Okay. Okay, so let's do this row up. Math submenu. This time we're creating a 1, so it's going to be E. Value is -7. Matrix is B. Row is 3. Give me a 1. Well, look at that, -1,650. Store it. Let's see here. Rows 1 and 2 stay the same. What's the next row operation? So I'm messing with the slide here. But, well, you can see my ink there, and you can also see the calculator. What's the next row up?
Would it be to get a 0 from the -8/7?
Yep, and how's that done?
I don't know.
The way it's going to get done is 8/7 of that plus that. Eight sevenths of row 3, because that's where the 1 is, in row 3 now, plus row 1. Guess we'll do it down here since this will be the last matrix, actually. 8/7 of row 3 plus row 1. That'll give us a 0 in row 1, column 3. We'll also need a 0 in row 2, column 3. How's that going to happen? Well, we'll hold off on that until we do this one. Matrix menu, math submenu. We need a times row plus because we're creating a 0. So F. Value is 8/7. Right? It's the negative of what we're trying to change into a 0. You know, we're trying to change that into a 0. So it's going to be the negative of that number. Matrix B. Row multiplied by is now 3 because that's where the 1 is. Row replaced is 1. Give me a 0. There it is. Store it. Okay. Write it. One more row up to get a 0 while preserving, you know, our progress so far. So that still has to be a 0, 1. But what's the row op that we're going to do to get a 0 right there in row 2, column 3? What's the value that we use? Well, that value is going to be the negative of -3/7. So we're going to do 3/7 of row 3, which is where the 1 is, plus row 2, and that'll be a new row 2. Matrix menu, math submenu, times row plus, we're creating a 0. Value is 3/7. Matrix is B. Row multiplied by is 3. Row replaced is 1. Give me a 0. Give me reduced row echelon form. Row 2 didn't change. Oh. Row replaced is 2. Okay. Forget that. I'm not saving that. Let's bring that back. Row multiplied by is 2. Yeah, don't save that. Row multiplied by is 3. row replaced is 2. Give me RREF. Thank you. Okay. Now we can, this is weird. We can see that we've got what we want right here. Okay. Looks like I have to run that thing because it's telling me matrix B is that lower matrix, which is not RREF. But if I go into entry here, second enter, and run that thing on matrix B, because that's what they're telling me B is, it should do it. Wait a second. Second enter, there it is. Row multiplied by 3, row replaces 2. Give me RREF. Store it. I wanted to store that one. Why won't it do that? Am I doing something wrong here? Okay, if that's my matrix B, do this. I've got RREF. I want to store in B. Okay. Okay. So the ordered triple solution, XYZ, right? X is negative 1450. Y is negative 600. Z is negative 1650. Ordered triple solution, XYZ, is negative 1450, negative 600, negative 1650. That's a screenshot that involves a screenshot. Okay, well, any question? Can I get my ink back? Thank you. Any question about this whole process? You're like, and the question that no one's going to ask is, that's I have to do all that to do one problem. Well, these are a beast anyway, so there's no getting around that. But if you want not to make any arithmetic mistakes, and you want credit, this is what you have to do. Okay, and this is the one way, the one approach. We didn't really get creative at all. We just responded to what we were given. When it was time to create a 0, we used times row plus. When it was time to create a 1, we used times row. And there were only certain arguments that worked there. So this is very different than, doing it algebraically with all the letters in it all the way through. So this is the one way to do it. my recommendation is you just learn this way. You make up your mind, okay, I'm committed to doing this. What I have in a lot of students who are slow to decide to commit to this is they struggle with all these problems or they don't do them. Then it comes like the very last day, and now all of a sudden they want to do it. So don't decide to do it later. Decide to do it now. Okay, so that was one of the things that we wanted to get done tonight.